Welcome to the Storage Developer Conference 2020 virtual event. This presentation is What's New in SNIA Swordfish for 2020. I'm Rochelle Alvers, the chair of the Scalable Storage Management Technical Work Group, which develops the SNIA Swordfish specification. First, a disclaimer. Just a reminder that the information in this presentation represents a snapshot of work in progress and is subject to change without notice. And then, the most important URL of the day, snia.org/swordfish. This is again a reminder and a pointer that all of the information we cover today can be found at snia.org/swordfish. Thank you. All right, so what are we going to talk about? So, there's a lot of new stuff that's been going on this year and being added to Swordfish. We've been very, very busy. We will talk about some of this stuff we'll talk about in detail. Some of it we'll just gloss over a little bit. So there's been a lot of new functionality added in the latest version of Swordfish, and there's also been a lot of functionality added in Redfish to support Swordfish and the work we'll be talking about. We've also added a lot of schema enhancements and simplifications. We've done some things like moving /storage to the service root. I talked a lot about in the previous presentation, which I hope you all watched, which was the Swordfish overview and deep dive about why that's really important from a client perspective. We'll talk a little bit more about that today, about what that looks like, and I'll reiterate that again. We've also spent one of our big focuses was adding support to map NVMe and NVMe-oF to Redfish and Swordfish. This has been a huge undertaking. We'll spend quite a bit of time talking about that. There's also been a lot of supporting work done to accelerate implementations. So there's new documents added to the Swordfish family. We'll talk about both of the new documents there. We're also pushing ISO standardization and we'll talk about which versions are where in the process. There's a ton of new mockups on Swordfish Mockups and a revamp. We'll show that. And then there's also two other new things going on, or enhanced areas, work going on in two other areas. Enhancements to the tools ecosystems, and the rollout of the Swordfish Conformance test program. Will give you a teaser of that, and then there'll be another presentation on both of those topics. There'll be a presentation talking about leveraging all of the tools to accelerate your implementations, and also an overview of the Swordfish Conformance test program. So we hope you catch both of those presentations later. All right, so talking about new functionality. One of the big ones from improving usability for clients has been to add /storage at the service root. This is required functionality for Swordfish implementations moving forward. So we've added support for that in the schema and profiles. One of the other things we have done is as I mentioned, we've added a lot of support for NVMe and NVMe-oF in both Redfish and Swordfish. So in the models and everything that I've talked about, the schema work is distributed between both Redfish and Swordfish. We have consolidated a lot of the documentation that we'll be delivering from SNIA, but there's mockups that are split between SNIA and DMTF. A lot of the fabric side work is actually has also been done in Redfish. So I'll try and call out a little bit of what's where, but a lot of the functionality and everything is captured in the new document, the Swordfish NVMe Model Overview and Mapping Guide. And the use cases, we're covering a lot of those also in the Swordfish Users Guide. There's also been a bunch of other additional ongoing updates, so schema updates to support implementation feedback and enhancement requests. A lot of things going into volume, storage pool, and storage groups. I won't actually dig into any of those today. They're all just detailed in our revision history for the various releases. We've had 2 releases out this year, 1.2.0 and 1.2.1 that just released. Okay, so from in the 1.2.0 plus timeframe, we are requiring that that Swordfish instances implement either instantiate at Redfish/v1/storage or put a reference link to their storage instance there. There's a couple of primary reasons for that. One is it completely simplifies your search and system traversal. So from a client perspective, this is going to really simplify the ability to find where your storage instance is in the system. So I'll highlight that by showing a couple of different options here. If you sat through the last presentation, I heard 4 different potential options for implementation. And I'll talk about that again here, but given that there's so many potential different ways that storage systems can be implemented, there's such a huge range, everything from a disk drive to JBOFs, JBODs to direct attach to standalone configurations, dedicated storage to shared storage. This is really a simplification mechanism for a client so they can always find where the storage is. All right, so a couple of different examples of that. Standalone configuration here. What a standalone configuration would be doing, this is typically, again, this would be, you would instantiate the storage instance in /redfish/v1/storage. These would be for configurations like an external storage device, a standalone system, shared storage systems, things like that. And so because the device is purely instantiated there, it'd be very easy to find there. Another option would be a system that is an integrated configuration. This is one where your storage is attached to a computer system. So the system is actually instantiated in the storage collection attached to the computer system. In this case, we're requiring that you put a reference link in /redfish/v1/storage that points to your storage instance so that the client can find it there. All right, so hopefully that explains, both the rationale for that and the different options. Moving on, next major chunk of functionality is NVMe and NVMe-oF mapping into Redfish and Swordfish. We have been working quite extensively in a 3-way joint effort between GMTF, NVMe Express, and SNIA. We've hosted all this work in my twig and have gotten a tremendous amount of work done. So the goal here is really to bring, effectively 2 different types of standards together and, find a way to map them, map these I'll say divergent models, and come up with a way to show how devices that follow the NVMe and NVMe-oF specs should be or shall be represented in a Redfish and Swordfish world. So this is not an implementation specification. This does not say how a specific implementation needs to be done. It basically said, because we don't, from a Redfish and Swordfish perspective, we don't care what low-level transport or where in the stack you convert from down into the native NVMe, whether you're using admin commands, whether you're using NVMe-MI, exactly which language you're using and where you translate it to that in the spec. That's an implementation choice. What it's doing is saying when you translate into that or translate back and forth, this is the model that you will have in Redfish and Swordfish. but it is defined in such a way that you can use NVMe or admin commands, both, either one or both, to use to fully populate the models. Our scope, we covered the NVMe Subsystem, NVMe-oF, and the new NVMe domain model. I'm not going to go into detail here, by the way, and talk about the specifics of what each component is. I'm going to talk about the mapping itself, because we have another presentation that will actually talk about, that will go into details on the NVMe-oF concepts. So this is a lot of the process that we used. The model reflects a unified view of all the device types. So we did not come up with divergent models for a drive versus a JBOF versus an array. Everything uses the same model and the same components. And so for each device type, it's just here's we'll use a subset of the model. So when I show you diagrams, they may not be the complete model and complete schema. They'll just be what's appropriate for that subset of a device. The next thing we did was we tried to, and we actually were successful at, trying to map to existing Redfish and Swordfish storage model, rather than coming up with a whole new, different model for NVMe and using a whole new set of concepts. The rationale there was looking at the NVMe models. It seemed like it was close enough that we could map things together by simply reusing, extending, and in a couple of cases kind of slightly twisting our usage. But for the most part, we were able to largely just map the objects together. We had basically one case where, one object, which I'll talk about in a minute, where we had to change the notion of how to use the object, but everything else mapped fairly cleanly, so we went with that. This is actually really good from a client perspective, because we built in a lot of backward compatibility for folks moving from traditional storage to NVMe. A lot of the concepts stay the same for them. All right, so we focused on 6 major NVMe or NVM objects, and these span for NVM drives, NVMe drives, and also some of them, like domains, are concepts that are coming out for NVMe-oF. So their endurance groups and sets are fairly complicated, complex concepts. So we have kind of a subset of these that are kind of the concepts that will be used generally and initially, and then as you grow, you'll add in the more complex concepts as well. So there's kind of a broad range of functionality covered. All right, the subsystem model, what I'll do here is I'll talk about the model and then show some examples. I won't go comprehensively through the examples, but just talk about what we did here. So this is a subsystem model. Like I said, what we tried to do was basically map the NVMe side and the model and how things worked to Redfish and Swordfish existing models, and we were largely successful with that. So the one exception here, so basically an NVMe subsystem, we're able to reuse the storage, because in the storage world, we treat the storage object as representing the subsystem. And so if you kind of back away a little bit and go abstractly, that works. The one thing that we weren't able to use kind of almost directly was storage controller. Storage controller in traditional storage is the logical controller, configures things. So this one we did have to modify quite a bit, because NVMe controllers are really logical entities and more for connectivity and control. But the rest of the objects did map fairly well. So storage pools we're able to use for endurance groups and sets, because those are largely for carving up and allocating capacity, albeit with different attributes than in typical storage devices. And they'll talk more about that in the later presentation. And then allocated volumes, or volumes down here, volumes and namespaces map well, because they're both, pools of block storage. Okay, and so that we kind of keep that same hierarchy, because it works well on both sides. So just what some of the sample instantiations. One of the things we did was we worked through all of these instantiations to make sure that the model was consistent. We created mockups for all except the two that are in yellow. We have an intent to go back and do them. We'll see if that actually happens. But all the rest of these, you'll find the mockups on swordfishmockups.com. I'm going to go through a couple of these just to kind of highlight the how this whole thing is working. So you can see the simple SSD implementation with a default endurance group and set. You can kind of see these are grayed out over here, or lightly blued out. What we have here is, because these are default, what that actually means in the NVMe space is that they don't actually need to be implemented. So what you see over here is you get implementations for these other objects, and then drive, drive falls into the chassis hierarchy. So the storage, controllers, and volumes fall into the logical hierarchy for Swordfish and Redfish. Drive falls into the physical hierarchy. And so this is where we represent like fru information and other information that's basically, over here we call this the physical element representation. So this is basically how we encapsulate the information you want to present in your system, but that isn't directly in the spec. So this is kind of all vendor unique or additional vendor information that you want to reflect. So that ends up mapping over to this physical view. The nice thing about this particular picture is this is exactly the same set of objects that a SAS or a SATA drive would report back today. So in terms of that consistency we were talking about, that mapped really very well. These particular bubbles are and diagrams are included, we call them the bubble diagrams for obvious reasons, are included to give kind of that redfish view. This is a very redfishy usage of representing things. This one kind of shows, all of the additional relationships and representations of the mockups. So this particular mockup you can find on swordfishmockup.com, but this just shows kind of another view of that same system and the various objects that are instantiated to support that. So you can see again that storage. This is a link to a reference link to the same instance. So there's that storage, controller, namespace, and drive. And then there's a little bit of additional, chassis, power, thermal information that shows up in that mockup as well. But basically another view of what that same kind of system would look like. All right, one more example, a JBOF. So there's lots and lots of different kinds of JBOF. So let me just put a disclaimer on what this one actually looks like. This one is basically a front-ending a bunch of PCIe drives, or PCIe front-end drives, not Ethernet attached or anything like that. So all it has is basically a physical chassis infrastructure and and so it's, effectively truly just an enclosure. So that is what's there. This picture kind of shows, okay, I've got an enclosure plus a set of drives. Now the mock-up, if you actually go look at the mock-up, actually has 7 drives, but the picture just looks ridiculous if I try and put 7 boxes on there. So this one just has 2. So one of this basically does is says, I have, the controller for the JBOF, and then I have these controllers, these elements are the ones for the drives. And so when you get kind of the aggregate view. So here is the same view of the JBOF with all of the various pieces in here. So you get like that admin controller, which is the JBOF, and then you get the IO controllers for each drive, and then again, there's only 2 of the drives shown. I know it's a little bit, if you tried to show all 7 drives, it'd be crazy. This one's actually a little bit easier to look at if you go actually look at the mockup itself and navigate around. So that's kind of how we developed that process. If you want to see a lot more details and explanations of things, please go look at the new mapping document. It's available at SNIA.org/swordfish. The next piece we worked on is adding the NVMe-oF. And so the NVMe over fabrics model, what this really does is it takes a lot of those same concepts and adds logical representations of them. So what we did here was we did 2 things, one of which is we reused over here in this gray box. We'll focus exclusively on this gray box here. We took those same components that we have in our storage hierarchy, or in our Redfish Swordfish hierarchy, that we're using for NVMe, the NVMe subsystem, and we reused those. So if you're going to have a logical subsystem or an exported subsystem, then it's going to be using exactly the same object as a subsystem, so it'd be storage. Same thing for the controllers, same thing for the namespaces. So all of these have they'll be exactly doing the same reuse. The other thing we did, and I mentioned early on that there was a huge contribution from the Redfish guys around on this portion from the fabrics model. We basically took and extended the fabrics model that has been developed in Redfish to cover a big chunk of the connectivity piece for the OF portion. All of these logical pieces are as well. But basically split this between here's these, object representation and the connectivity representation. So the connectivity representation is over here in this red part. So the allowed hosts, the logical port representation is all done in the fabrics. So all of this, the device's view of connectivity is represented here. And again, those mockups. Sorry, one more piece here, and then we'll jump onto the sample instantiations. The other piece we added to layer on top of that is NVMe domains. So domains can be constructed out of various elements in the subsystem. Domains are basically a mechanism to take a subsystem and break it into parts for things like fault management and power management reasons in a fabrics environment. So this basically shows, I can go take controllers or namespaces or ports and carve them up into appropriate So the sample instantiations, there's a couple of different ones here. This is actually the simpler one. This is basically, again, looking at that drive model, but extending a drive model to have an NVMe-oF attached. So you get leveraging existing network infrastructure. So again, we extend, we add over here to the physical representation this, and it corresponds to this physical element stuff, port information and Ethernet attached configuration information. So that corresponds to the network adapter, network port, network device function. And that extends basically all this other stuff that you would see directly on a regular drive. And then you add the Ethernet attach or the IP attach configuration information extended there. And here is its bubble. You can see the green down here being that attached Ethernet, and the connectivity from the added I/O connectivity from this is basically the new piece, one of the new pieces. The additional link that isn't there from a regular NVMe subsystem to one with the NVMe-oF connectivity. All right, so that's a hopefully a little bit of a flyover, although I kind of went relatively deep into the NVMe-oF constructs, and Raj and KK will go into a lot more detail. Some of the other things we've been working on, I mentioned a couple of new documents. We rolled out earlier this year the Swordfish Error Handling Guide. This document has goes through a whole bunch of the status codes and their usage for handling for errors and sample error messages, provides examples of use for a large number of cases. The document we just rolled out in August is the Swordfish NVMe Model Overview and Mapping Guide. This is a 166-page document that defines a model to manage NVMe and NVMe storage systems, and provides detailed mapping between the NVMe specs and the Redfish and Swordfish specifications. So it covers all the diagrams you've already seen, plus a bunch more, explains their usage, and then talks in detail about both the mockups as well as a bunch of additional properties that we've added. We do not believe we're done by any stretch of the imagination. This is clearly, an initial pass through, but we are extremely happy with the amount of work we've gotten done, and view it as a really good starting point. So we're looking forward to folks getting a hold of it and starting to work on some implementations and finding out what we missed. I've talked a lot about mockups. One of the things we've done is revamped the Swordfish mockup site and done a whole bunch of cleanup on the mockups themselves. So there's mockups in these 4 categories. A whole bunch of obviously new NVMe and NVMe-oF mockups, but also added new mockups to correspond to the standalone configuration, the integrated configuration, and then we had a whole bunch of existing service-based configurations, and so those have all been wrapped up into this hosted service configuration mockups. If there are other mockups that people have created and would like to donate, you can contact me and I will run them through our mockup validator and for correctness, and work with you on getting those posted as well. We would love to have additional mockups to add to the site. All right, I mentioned ISO standardization. We have started sending Swordfish version 1.1.0, I believe variant C, started through the process to become an ISO spec. It takes a little while, so we expect that to be complete sometime in 2021, and then it will be available as an international standard. Next area, we are we have continually working on an expanded tools ecosystem. One of the things we have added for the folks working within the twig is an automated offline build and test infrastructure for the Swordfish schema and mockup contributors. And that's a bit of a mouthful, so let me explain what that is. We have been incrementing our CI for our GitHub infrastructure for our schema and test and mockups. A lot of that actually is work that's coming from Redfish. I don't want to make it sound like Swordfish is doing it all. We leverage tremendously. But as we're building that up, we now have the ability to run all of those tools in an automated framework offline, as opposed to just in the CI infrastructure on check-in. So anyone who is looking at, writing schema or trying to contribute schema can actually take those, as long as you're a member of the twig, you can actually take those tools and run them and test your schema. You can also run all of our existing mockup tests against those tools offline, against mockups offline, and use them to test the mockups for quite a bit of validity. It doesn't actually, there's quite a few things that it doesn't check for, but it's getting a lot better. But so you can actually do a lot of checks on mockups and see how you're doing. So those are some really good new tools that are available for people to start working with. We've also got some new open source tools. I talked about this a little bit, and there will be a lot more details in the tools presentation coming later today. There's a new Windows PowerShell toolkit that's been getting a lot of attention this year. It's an open source tool for Windows developers. It will also run on Linux, but to help accelerate Swordfish development if that is your preferred development environment. Okay, next one, we talked about, Swordfish CTP rolling out this year. What is that? So Swordfish, the Swordfish Conformance Test Program is a vendor-neutral test suite to validate conformance to the SNIA Swordfish specification. So you can come in, run the tests. If you pass the test, you can, and are part of the program, you can get you can advertise your test results, or get your test results posted, I should say, on the SNIA Swordfish CTP website, and point folks there. You can also get the SNIA Swordfish CTP logo to use on your products as a mechanism to indicate that you have passed conformance. The logo will actually indicate, it will be versioned and will indicate the and correspond to the version of the SNIA Swordfish bundle, which includes the profiles that are part of the test, that is in use there. The CTP uses both the Redfish spec, Swordfish spec, and the profiles to determine compliance, and we use tests around all of those. And as you, so the profiles themselves are the coded instantiations of functionality that the implementations can advertise as customer features. So if you're going to implement a customer feature and advertise that you're supporting it, Swordfish CTP is the way to verify for clients, for your customers and your clients to come in and validate that yes, you actually are conforming to the spec when you do that. So where is the program? I said we're rolling it out this year. It is in development. The framework and test infrastructure is in place. We have the dev team working on integration, automated and enhanced tests. We are actually now working with companies on testing the tests. So the program launch will be coming very soon. If you're interested in joining the CTP program, contact us at storagemanagement@snia.org. All right, that's our update on everything that's going on and what's new this year. I hope you feel like that's been as much as I do. We've been just tremendously busy this year working on getting all that stuff done. Thank you for watching. If you want to remember the key URL there is snia.org/swordfish. If you need looking for spots to go ask questions, and you're not a SNIA member, you can, or a Twig member, you can go to swordfishforum.com. If you'd like to join, check us out at snia.org/members. And we'd also love to have you join the SNIA Storage Management Initiative to help promote the technologies. Please take a moment to rate this session. Thank you for watching.